Hello. Uh, this small tutorial is to try to introduce the idea of Booleans in the Java language. I'm going to use some tests that were set up using this KISS framework. Um, and I'm also going to be using the get version control to help manage which branches I'm on. So right now I'm in the Hi project. The previous tutorial explained how to start up a get version control infrastructure for your packet for your project. That's the little soup can next to the coffee cup, um, and um, and so I'm going to go ahead and I'm on the master branch, and I'm going to go ahead and save that with a nice name. So under Git, I'm going to go ahead and uh, create a tag right there, and I will just call this Hi version. How about version 1.0? So I'm going to call that the 1.0 version, and not sure why I must have that message in there. Don't let me change that. So I'm going to leave that and go version 1.0, version master, create. Okay, so I have a tagged version. I'm calling it version 1.0 of this version of the software. And now I'm going to move on to a different branch so that so they can introduce the Boolean business. So under Hi, right click, get branch and tag, create branch. Now I have already done this, but this is a step you have to take. So create branch and branch name Booleans. Every time you want to introduce a new feature into your program, a good idea is to create a new branch in which you do that, and that way you don't break all the different sort of versions of the software. So hopefully master stays in pretty good shape, and then master just slowly improves while over in the other little branches is where all your sort of lab work is done. So this branch name is called Booleans. I am still amazed that I can't change that. Okay, and then I'm not allowed to hit create because, well, in my case, I've already created that. In your case, just go ahead and create the branch, and then this will be a version of the software which is in the Boolean branch. All right. So, but in my case, I'll just check out the created branch. Oh, I still can't create it because, well, it's done. Okay, so right click. Let me go ahead and check out that branch. So git check out. Maybe it's under branch and tag. Switch to branch. Okay, so we're going to switch to the branch that we hopefully just created. I have two branches here. I'm going to switch to the Boolean branch and switch. So now this software represents the Boolean branch. Even though it's the same to start with, it is now tracking the differences that on a different flow than what would have been the master branch. So here's my app.java in the Boolean branch now, and let's start talking about some Boolean values. So void test booleans. So in my test booleans, let's just go through some basic operations. So the first thing is if I want to declare the idea that there is a boolean I need to work with at some point, a variable, boolean is hot is equal to true, for example. That would be an example of declaring a variable called is hot, which is Boolean, which means it could be either true or false. And initially, inside of this test Booleans little block, its value is true. So Boolean is cold, then would be the logical opposite of is hot, although okay, so this is illustrating the not operator. So the bang right here, an exclamation point, is the operator that takes true things and turn them into false things, or false things and turning them into true things. So to create the little, this is called a truth table. So assert not true, that turns out to be equal to false, and assert that not false, well, that turns out to be equal to true. So here's a declaration just to illustrate how you declare these sorts of variables. And here are some facts about true and false things that if you use not, it maps true to false and false to true. And if we test that, then good. So we have some tests of Boolean started and ended, and apparently all that works out. All right. So the next thing that's true is just how do you print those values out? So print, then say if I print out the value is hot, like that, and execute that. In my test right there, notice I get the word true. So some languages will choose to represent on the console down here true with the number 1, but Java uses the word true just like in the internals of the language. When you say true here, if you print it out, you get true as well. And so to turn that into something that can be verified as a test without having to look at output, otherwise this is not an automated test, right? Me as a user looking at that little word down there, I need a much better choice here in this case is try close out equals out expect the word true if I print that out like that. So if I run that, I don't see true in my test anymore as far as output down here on the console, but this is a little automated test that asserts that when I do print out what is hot is, since it's true up there, I should see the word true, and in fact, since it passes the test, that must be true. So perhaps not surprisingly, then I should expect the word falses, when I print out is cold up there. Okay? And run that. Like that. That's the output. I suppose we should go ahead and validate some things about the input. So if I try to, first I'll do it by hand. So if I just say Boolean just Q equals read Boolean, like what sort of things would you expect to have to type to make that all work out? So Boolean Q read Boolean. If I run that, this is a strange moment. Like I'll run this, and right there, test Boolean started, and like nothing happens. It's because I'm just asking a question without really reporting that I'm out here. So this is going to wait forever. Well, it's waiting for me to type something, and I hope you believe that if I hit true, type true and return that, like that worked, and Q then becomes true. So if I want true to be in there as the value of Q when I read a Boolean, I should type out true, and that would work out. So to turn that again into a test, so try close and equals in provide. If I provide the word true, then I should be able to assert that read Boolean is actually going to give me a true back, like that. So now that's an automated version of that, so I don't have to actually run anything, and look at that, that works. And then of course the false version. So if I provide the word false when I read something in, then when I read that, use the read command, I should get false back into my program. So here's the basic declarations. Here's some basic just true false logic here. This is input and output. So if I try to output trues and falses, that's what I get. If I'm trying to get things in, that's how I expect it. So now the next important set of logical operators is called and or, and they involve more than one value at a time. And so let's do and first. So / is a comment, but this is a way to remind you of something. So and is true only when both sides are true. So and is a logical operator. It takes two Boolean values and creates a third one. And the in Java, and is that. So two ampersands right next to each other is how you represent the and operator. And so let me just create what's called a truth table for and. So assert, if I take a true and with another true, well, both sides are true, so I would expect that to be a true result. Assert true and false, well, both sides are not true, so that has to be false. Assert false and true, well, one side is false, so that has to be false. And then last case, false and false, that has to be false. So just point out, and isn't true very much. It's only true when both sides are true, which is what I try to write in words here, and what I prove is true. I guess let's go prove that it's true by running our little automated tests. Oh, look, they still pass. So these are all true things about the and statement. The important other thing about the and statement here is when the first argument is false, there's no reason to really move on and figure out what the second argument is, because no matter what it's going to be, it has to be either true or false, because it's a Boolean value. But no matter which one it turns out to be, the answer of the and is going to be false, because they both have to be true. So down here, this bottom two cases is an example of what's called a shortcut. I'm sorry, short circuit. So a short circuit evaluation, what happens is, if this is sort of a complicated set of expressions on the two sides, what happens is, if the first one, it evaluates the operator on the left followed by the one on the right. If the one on the left, the first operator, is false, it doesn't bother going on and trying to evaluate the thing on the right. So the thing on the right might be expensive to calculate, or it might actually contain an error because like this checks whether it's going to work out, and then this other side actually does something involving something that might otherwise be a bad thing had this not been checked first. So you don't always evaluate this side. In Java, the short-circuited logical AND operator assures that if the thing starts out with false, then the result's going to be false, but it doesn't ever even bother calculating this second part. Okay, so I just wanted to point that out. I guess actually let's actually assert that let's make a test. So void. Actually, this one's going to return a Boolean. Boolean. Just broken. And this is my chance to actually throw an error of some sort. So I'll just throw, instead of returning a value, I'm going to throw a new kind of error. Errors are the exceptions that we've been seeing with assertions and that sort of stuff. In fact, actually, I guess we can. That's the easiest thing. We'll just assert false. So this assertion will certainly fail. So instead of returning a true or a false, this will just break. Oh, that's interesting. That's required. So we'll return false down here. It never gets to that line of code because the assert false breaks before it ever gets there. But now down here, so we're not for the short circuiting and broken equals false, like that. So this is a little method. It looks like it's supposed to return a Boolean, but in fact it never gets there because this error happens instead. But perhaps surprisingly, even though it looks like I'm trying to invoke a broken method in here that should throw an assertion error, in fact, this broken in here is never called because of the short circuiting. So the fact that this returns anything at all is just because broken is never called, so it never gets to the assertion. So this is an illustration of the short circuit. So the broken thing never even gets called because of the short circuiting. All right, so now that's and now let's or. So or is the one of the other important overall logic variables. So or is true if either side is true. So, and then in Java, just OR is like that. So to think of the OR operation, you use these two pipe symbols, so pipe, pipe, and that's called OR. And then just to illustrate the truth table there, so just following along, true and true, sorry, I just said or true. Well, both sides are true, so either one is true, so that's true. And then assert, so true or false. Well, at least one of those sides is true, so then that's true. And then assert false or true. Well, one side is true, so that's true. And then assert false or false, the last possible case. Well, now both sides are false, so now finally it's false. So just want to point out in our truth table up here, so and is sort of not true that much. It's true only when both sides are true. So and likes to be false if you like, or it likes to be true. So it's only false once. It's only false when both are false. Okay, so the or is, again, it's true if either side is true, and then this is an illustration of that. Let's test that, make sure that we don't have any mistakes about what we think is true versus what seems to be true in the language. So here's the and idea, and then here's the or idea. And then there's actually an idea of short circuit as well on or, because if you look at the or cases down here, one thing that is true is if the first argument here is true, the argument on the left is true, then there's no reason to go on and figure out the argument on the right because, well, it doesn't matter, right? So true or anything is true. And so because of that, this side is short-circuited here. Short circuit there, and a short circuit there. So those are short-circuited, and then just to illustrate that that is true, that's how that works out. If I can assert true or anything, even that something that if I actually ever called would break, I can still figure out that that should be true, and that's what Java does. So Java ignores, doesn't try to invoke anything that happens on this side in an OR statement, because once it realizes that the first part is true, this short circuit business says, well, don't worry about the second part because it doesn't really matter which way it's going to turn out. True or anything should be true, and so this is an illustration of the short circuit, like that. Okay, so there's the basic Boolean only operators that are available in the language, and so the last part I'm going to put in here is just the most elementary branching that you use the Booleans for is if statements. So let's create a little method down here that takes a Boolean and decides something using an if statement. So we'll just void if statement taking some Boolean value P, because it's so generic. How about, yeah, we'll just call it P. All right, so an if statement, the nature of an if statement looks like this. You have if some condition P, apparently, which is either true or false, and then we'll print out P was true as a message, and then otherwise, and it's optional. You don't have to put an else clause, but println P was false. So we generate two different branches in our program in this little method called if statement. And the if statement, so you give it a case like P, and then it goes on and goes through these cases, and will generate a few print statements like that. So I'm thinking, well, I might as well show you a compound if. So there's a Boolean P. There's more you could put in the middle. So we can now have like a Boolean Q also. And so instead of just having an else in here, you can also have an else and then another if. So else if q. So for the only way you could get there would be println. The only way you get there is p would have to be false, otherwise I would have done the first if statement. Was false, and q. In fact, let's use present tense. P is true. Here, P is false. That's the only way we would have gotten there. And Q is true. That's the only way we would have gotten in there. All right. And you can have as many else ifs chaining along as you like, including none of them. And then finally, at the bottom of all those ifs and then as many else ifs as you need, you can have an else. And the only way you get into there with two of those things would be P is false and Q is false. So let's just sort of explain how that happens, right? So for an if statement, basically this is a structure, so everything but the if part is optional. You can leave out the else blocks, the else if blocks, and you can leave out the else blocks if they're not useful to you. But what happens is if, and then some Boolean condition thing which will work out to be either true or false. If that is true, then this part is called the then part, and this is what executes. So in this case, it would turn out that the only way you'd get in there is if P were true. If that's not true, well then that must be that P is false. And now we're going to check something else. We'll check Q. Well, the only way you get this far is if P was false, and then now we're going to check whether Q is true. If it is true, then well, now we fall in and we drop into this case. Now, if Q were false, well, now we're to the case where both P had to be false, because otherwise, if it were true, it would have gotten there. And then if Q were true, then it would have gotten there. So our only options left is that. So by the way, the value of Q doesn't matter here, right? So if P, then if P is true, we might and Q is, and we actually don't know, but so we'll just print out the value whatever comes in there. So println out P like that. So P and Q is true or false here. It doesn't matter. All right. So let's now play with this. So what kind of output do we expect out of this thing? So try, close out, expect. So to get to the first case, there's actually two ways. Out expect, P is true and Q is false. There's no period in my sentence down there. So expect that. I need an equal sign in there. Expect that kind of message if I use my if statement with true and false, like that. All right, if spell statement correctly, like that. So let's slow and steady make sure that that works out. Oh, look, that worked out. All right, so now my next possible case, right, is true. If I pass in true there, my if statement should say that. And then so whether I print out whether Q is false or true or false, I end up falling into this little branch, and I always get the first if statement executed. All right, so P is true, Q is true. So then so those are those two cases. Except I should actually turn them into those two cases. So if I put in a false, it should come out with false there. All right, and then let's test the last ones. So this is all the versions of an if statement, right? So test P is true and Q. So if P is false, what happens there? We should get out. So P is false. How do you get to this place? Well, P should be false and Q should be true. So it has to get out of not getting into that step, but get into getting into that step. So then that would be switching these around, false and true, like that, and then finally if they're both false, then I get to the absolute else case at the bottom there, and in that case, ooh, that should be true up there, huh? Okay, so here's my 4 possible cases for this little illustration of the if statement. So this is an example of if statements with possible else clauses, else if clauses, and optional else clauses like that. So that's the basic structure of an if statement like that. You could have as many else clauses as you need, QRST like that. But here's your basic if statement, and this is how you would expect it to work when you're sending commands. So let's just test it in different cases. So yeah, so now it all works. And an if statement, it's hard to go very far without needing to make some conditional choice in your program. And so here's the basic notation in Java about how you write if statements. So if, logical, some block of when it's true, and as many else if, and then a block of what do you want to do if that case doesn't work, and you keep on trying different cases until you fall through finally to else. And then if none of the other cases worked out, then here's an else clause to go ahead and drop into if everything else worked out. Failed to work out. And that's the basic structure of Booleans in the language. And now I will save that and put it in my version control. So git add, and then git commit. Commit message is now illustrated Booleans. Like that. Got my app Java thing, hit commit. Maybe double check. Yep, passes all my tests. I got a version of it in my version control, so I can go back to it if I want to compare things. And that is the end of the very first introduction to Booleans in the Java language, and a bunch of illustrations of how you might use it in the language to see how it should work.